Welcome to our What's New for SOLIDWORKS 2026 series. Over the next few minutes, I'll take you through some of the updates for structural simulation. Whether you're working on a simple part or a complex assembly, integrating simulation into your workflow has never been easier with SOLIDWORKS 2026. Here we're looking at a sub-assembly that supports and stabilises the rear of a horizontal drill, while also withstanding extensive thrust force from the drill head. This study is almost fully defined using a mix of shells, solids, beams, along with some pin connectors. To complete the setup, we need to apply the main load from a large hydraulic cylinder. A remote load is the best way to represent this, but until now it's been restricted in where it could be applied. New in Simulation 2026, remote loads and remote masses can now be applied directly to shell edges. For engineers analysing sheet metal or thin plate structures, this makes it much easier to replicate real-world loading conditions. On running the study, it looks like something is missing. This study isn't fully defined. In Simulation 2026, the error dialog now tells you exactly which body is missing a material or which mesh control caused the issue. This makes it much faster to fix setup problems, especially in large studies with many components. The analysis is complete and we're reviewing the results starting with displacement. Displacement plots are always a key metric, and new in SOLIDWORKS Simulation 2026, users can now define rotational displacement plots relative to the X, Y and Z directions. These are reported in either radians or degrees. In this case, we can see significant rotation that would cause operational issues. This model is set up primarily using shell elements, ideal for analysing thin plates while ensuring fast solve times and retaining accuracy. Typically, a thickness to span ratio is used to decide between thin and thick shells, where thick shells will account for shear stresses through the plate's midplane. New in Simulation 2026, you can now set the default shell type directly in your simulation options, with thick shells as the new default. To reduce rotation, we can adjust the plate thickness through the shell manager. Increasing the load-bearing plate and rerunning the study shows a substantial reduction in rotational deflection, bringing performance within a safe operating range. But static loading is only part of the story. During drilling, dynamic forces can introduce additional stresses. That's why we've created a random vibration study to identify potential resonance issues. New in Simulation 2026, connector reaction forces can now be calculated in dynamic response studies for pin connectors. Since this model heavily relies on pin joints to transfer loads, understanding how they behave under vibration is critical to designing a robust structure. Buckling analysis is a critical step in understanding when structures may fail under load. Let's take a look at this frame that needs to withstand 40,000 newtons of force per beam, or a total of 160,000 newtons. This study is almost fully defined using joint groups, materials, fixtures and gravity. To complete the setup, we need to apply the acting forces on the top beams. In SOLIDWORKS Simulation 2026, you can now define total force across multiple beams, or apply distributed mass per item, giving you precise control over how loads are applied. This enhancement streamlines setups by matching the way engineers think about real-world structures, distributing weight evenly along each beam, or applying a single combined load to multiple members. For users, that means a lot less manual work, fewer errors, and more accurate results, whether you're validating a lightweight frame, testing a truss under heavy loads, or ensuring your design meets safety requirements. This structure is also being reviewed with a response spectrum analysis to evaluate how it performs under seismic loading. To complete the setup, we need to account for heavy equipment mounted on the frame. In the past, that required modelling the full geometry or leaving its effects out altogether. With SOLIDWORKS Simulation 2026, a remote mass can now be assigned directly in a response spectrum analysis. This allows us to represent mounted equipment as a lumped mass, rigidly tied to the structure without adding unnecessary details. For engineers, this keeps the model lighter, accelerates solving, and still provides accurate results. In previous versions, buckling studies often reported negative load factors, representing load reversal and indicating instability under compression applied in the opposite direction of the defined load, which complicates results interpretation. SOLIDWORKS Simulation 2026 introduces a new option to extract positive buckling factors only. When enabled, the solver automatically filters out negative modes and reports only the critical positive load factors. This enhancement reduces clutter, accelerates interpretation, and provides more reliable insights into when and how your beam structures could buckle. SOLIDWORKS Simulation 2026 gives engineers the ability to apply distributed remote loads on shell edges, utilize a new UI for validity checks, plot rotation displacement in radians or degrees, define the default shell type, use random vibration studies to extract forces for pins, apply total forces across beams, run quicker seismic studies, and filter out negative buckling modes. Please join us in our next video for what's new in SOLIDWORKS Plastics 2026.